Well, I'd like to welcome everybody who's taken time off on a Sunday at the end of the month to join us once again in our ongoing programs of education in gemology by Gemquest. And first of all, thank you very much, Clemens, for your invaluable help in making sure that we get this Zoom recording and have the availability of a Zoom program for people to be able to attend. I think that it's important also to offer my initial apologies to Amanda, who probably had a shock to find out she was going to be doing a talk today. When it turned out it was clearly a typographical error and someone put the wrong name in the wrong place. But at any rate, I want to very much welcome Sammantha for her second program on inclusions. And I've always thought that this is probably one of the most key areas in unlocking the secrets of many of the stones that we have to look at and determine their origins or their identification, their natural or unnatural sources, and so on. And so inclusions are probably one of the most important secondary knowledge areas that we have to be effective in identifying and working with gems. So just to give you a repeat of what this long and incredible introduction for Sammantha. Sammantha has a lot of letters after her name. For someone so young, I think she's used a time machine or something to allow her to have all these extra FGA, DGA, FIRV, MGBA, and is an independent jewelry valuer based in Glasgow. She has over 20 years of experience, again, I don't know how, in the industry and worked in high-end jewelry and watch sales before finding her passion for gemology and valuations. She is a fellow of GEMA and a past winner of the Gordon Ness Trophy for top mark in the gemology diploma exam. She also holds the diamond diploma with merit from GEMA and is also a mentor and tutor for new and student valuers as part of the National Association of Jewelers Institute of Registered Valuers. A passion of Sammantha's when she is not in the office providing valuations is photomicrography, for which I am absolutely jealous because I haven't mastered this yet. Photographing gemstones and their inclusions under the microscope, and she can spend quite often, hours catching just the right image to be shared online and also weekly in the Roskin Gem News Report, where she has a magazine page. So today, part two, a deeper dive into inclusions, and we're going to learn a lot more at a different level. I'm very much looking forward to seeing the incredible image and the sharing of knowledge that Sammantha has about inclusions. And I'd like to welcome you all, and in particular, welcome Sammantha.
Thank you, Ray. I always, when I hear my introduction, is that me? It seems so strange to hear when someone reads it out. Thank you, everyone, for coming again. It's so nice to see all these lovely names and familiar faces on the screen. Um, Last time we had a more light program looking at inclusions and lots of pretty pictures. This time we'll still have lots of pretty pictures, always important, but I wanted to go a tiny little bit deeper into what inclusions really are. So I hope you enjoy. For those who are gemologists, this will be a little refresher, a little recap of what you learned back in the day. And for others, hopefully you'll learn something new. So, she says, as it doesn't work. Oh, there we are. So our objectives really today are to look at types of inclusions, uh, some collectible inclusions and inclusions which can add value to gemstones, some inclusions in diamonds, and another part which I've titled Chasing Rainbows, which is a personal favourite of mine. So I've added some very pretty pictures for the end. I think that's what a lot of us are here to look at. So We'll go a little bit into types of inclusions first of all, and look at inclusion types when we look at age-related. So this is when the inclusion formed within the stone. And we're just going to look at solid inclusion types today, not fluid inclusion types. So we have the protogenic inclusions, syngenetic, and epigenetic. And we're going to look at those more closely. Just for reference, the image on the right hand side there is an image I took recently of covalite in quartz, sometimes known as pink fire quartz. It's very pretty, forms these lovely hexagonal platelets in the stone. So, first of all, what I should mention, sorry, I've tried to include as many of my images as I can. However, there are cases where I couldn't do that, in which case you'll see a note to say who the images are from. I always like to make sure I credit the right people. So, if we look at protogenetic inclusions first of all, the Greek proto meaning first or earliest, and genesis gives us the format of our word. These are inclusions which were formed before the growth of our host crystal. And what happens here is where the solution is looking to form in particularly hydrothermal deposits, the solution itself doesn't have space to grow, and it has to dissolve or move some particles, some pieces of the host rock. These are often partly or rhyolitic dissolved inclusions within the stone. Some protogenetic inclusions that we might find, for example, are actinolite and emerald, epidote and quartz, and spinel and ruby. But what we have on the right hand side here in this lovely image is what a lot of us will know as the Trappichet emerald. The black, I use the mouse here just to point out, these black legs or spoke inclusions have been found to contain schist from the host rock when the emerald was forming, and of course it produces these really beautiful, fantastic Trappichet emeralds. Oh, there we go. Carbonous materials. Oh, sorry, I said schist, excuse me, sorry, shell host rock. We move on to syngenetic. So syn or together and genesis to form our word. These inclusions are formed simultaneously with the host crystal, so not before or after. They can be found in one particular area of the crystal, or they may be dispersed throughout the host, and that will all depend on growth conditions, temperature, if there's any geological events, etc., going on during the growth process. Some types of syngenetic inclusions will be pyrite and quartz, which I've got on the right hand side there, spessartine and aquamarine, which I'll show you later on, and also primary rutile and corundum. The image on the right hand side there is one of mine. This is a lovely cube of pyrite within quartz from Brazil. This was taken under cross-polarizing filter, so you can see some interference colours showing on the pyrite there, showing off that metallic luster, which is quite pretty. Moving on to the final age-related, epigenetic inclusions. We're taking this from the Greek epi and genesis. So these inclusions form after the host crystal growth is complete. Now that can be immediately after, or it can be millions of years after. So it really does not have a definitive timeline. So in this particular case, other solutions may seep into fractures or cleavages within the host crystal and leave behind dissolved solutions. These are partly amorphous materials and partly crystalline materials. Sometimes what will happen is that they recrystallize inside these fractures or cleavages. This an example.
Which phone number, contact or device do you want to call?
Sorry, my Alexa thinks I'm talking to. I just started talking to. Sorry.
Please say that again.
Sorry. Sorry. So an example of this is emerald fillers, diamond fracture fillers, as well. Oh, sorry. What I wanted to point out, this image on the right-hand side here, is actually a spinel, which had some natural fractures, and at some point a liquid has gotten in, and you can see we've got some thin film liquids around here, and there's also some what looks like partially healed areas in the fracture, which are these materials which have recrystallized. So another subcategory, if you like, of epigenetic inclusions are these egg solution inclusions. So these are formed after the host growth as before. One particular example of this is rutile silk, which you'll see in my image here, which occurs in corundum. So as you can imagine, the crystal itself is formed at very high temperatures, and as that solution, the crystal is grown, it starts to cool very slowly. And in this particular case, the titanium alloys ions, which were a defect essentially in the crystal, begin to migrate just to very short distances throughout the crystal lattice, and they form in a very specific pattern. On the right here, you can see that pattern. We've got 60 and 120 degree angle intersections of these rutile needles, forms this lovely hexagonal pattern, which of course is mimicking the trigonal crystal system. This is a recent image. This is a Sri Lankan blue to purple colour change sapphire. I will always say it's low or no heat. I don't ever like to say that something is definitively no heat. And if you're interested in that topic, I would suggest looking into the work that Billy Hughes and Wim Triest have been doing, looking at how inclusions change in the heating process. Oh, excuse me, sorry. So those were our age-related inclusions types. Now let's have a look at the phases. So image 1 here, we have single phase inclusions. In this particular case, most likely fluorapatite crystal within a spinel. So we have that solid inclusion. We then have the liquid, which we just talked about in a couple of slides ago. And then in the last image here, we have gas bubbles. So this is a moldavite crystal, and you can see these lovely gas bubbles and swirls within the natural moldavite, which is lovely. And this an image by Igor Gavrilenko from his website Gems Inclusions, which is really fantastic. If we look at the phase of the inclusion, so how many phases we have going on in each one. We can have two phase inclusions. So we have a cavity here within the crystal and a liquid and vapor, although it can be other combinations, but most likely liquid and vapor have formed in that cavity. We can also have three-phase inclusions. So we have our liquid, solid, and a vapor most commonly. Of course, we see that often in emeralds. This particular image on the right is a Zambian emerald, which you can see if you look at this area here, has the cavity, we have a liquid, we have a vapor, gas bubble, and a solid crystal within that cavity also. Another type of inclusion we can find is the multi-phase inclusion. This particular image on the right hand side here has two different liquids, so water down in this very small area of water, the petroleum which you see, we've also have the gas bubble, the vapor floating in there, and these bituminous particles which are floating around in there too. This particular crystal is lovely. This is a quartz from Pakistan. The fun thing you can do with these is shine your UV torch on those, and that petroleum lights up a beautiful blue, aqua blue colour, which is lovely. And as you rotate the crystal, you'll actually see those particles and the gas bubble moving around, which is really nice. So moving on to our collectible inclusions. We have our demontoid garnet with a horsetail inclusion. I think that's quite a favourite of many people. We have the chromite crystal in the centre here, the epicentre of everything, and these chrysotile fibres which radiate outwards, forming this beautiful horsetail. This particular stone is from the Ural Mountains in Russia. However, they can also be found in demontoids from Iran and Italy. Now, I know some people don't like to call them horsetails if they come from Iran and Italy. They call them horsetail-like or something like that, but I'll leave that up to personal preference. Another type of collectible inclusion, very much more for the mineral collector, I would say, than the general public. This particular image is of spessartine in aquamarine, so spessartine garnet in aquamarine from the Gondi mine in Shigar, Pakistan. It forms in this beautiful plane, is in line with the basal plane, just beautiful, a little sea of garnet crystals. It's really lovely. Now, quartz itself has so many collectible inclusions. The nice thing about quartz is, of course, it's much more affordable for everyone. So if you enjoy photomicrography, it's the best way to get into it, picking up this sort of material. On the left-hand side there, what we have is what's not in the image because it's hidden by the rutile, is a crystal of brookite, and then these beautiful silver rutile needles are sprouting beautifully from the brookite. And then on the right hand side, this is a material I purchased in Tucson this year, which was called pom pom quartz. Now, I believe they are still in the process of working out exactly what the inclusions are. When I bought this from Marco at Gems and Gems, he told me that there was some uh, off to the lab in Rome, and he was waiting the results. So, if anyone does know anything further, you can let me know afterwards. Another type of collectible inclusion in quartz. We saw the pyrite before in the Brazilian quartz. Now, this is a pyrite in amethyst. This particular piece is from Thunder Bay in Canada, and so slightly more unusual origin, which collectors will like again. But I think this one's particularly beautiful in the way that the cube is just perfectly formed. This particular image is also taken under cross-polarizing filters, so you'll see these interference colours running around here. This is just where there was a natural fracture within the stone, and it's just kind of radiated towards the pyrite crystal there. This is another Tucson buy actually this year. It was hematite and quartz. This particular specimen has intermittent growth, so stopping and starting, as you can see throughout the stone, where it stops, then starts again, stops and starts again. I think that's a particularly nice collector's piece. So we're going to move on a little bit to diamond inclusions. I'm not going to tell you again all about VS1 and SI1 diamonds and that sort of thing. We're just going to look at interesting inclusions that can be found in diamonds. We all know these features, which in the images here. But what I'm most interested in is the really interesting inclusions. Now, I would suggest that if you are interested in diamond inclusions and more interesting diamond inclusions, have a look at the GIA website. They have research scientists who work on this all day long, every day, trying to come up with the facts about origins of diamonds and this sort of thing. So they are the really experts. Unfortunately, I don't get to photograph many interesting diamond inclusions, so I have borrowed these from GIA. Now, on the left, you can see this image with the lovely little orange garnet up here, and also a kyanite, which is really lovely. If we're getting down into the scientific side of things, this would tell us that this particular diamond came from eclogite rock, but that could be another talk for another day. That could go on for hours. Also on the right hand side here, I saw that they called this the snail was the nickname for this. I kind of think it looks more like a caterpillar. It reminds me of the caterpillar from Alice in Wonderland. I can see him there. But in this particular image, you've got the chrome dioxide in this body part, if you like, and then pyrope garnet in this area. With these being chromium-rich inclusions, we might be looking at more likely a peridotitic rock that these diamonds had come from. If we look at synthetic diamonds, as a valuer, this is something that I have to do every day as part of my research of diamonds. This particular image here shows a HPHT synthetic grown diamond, and it has these metallic rod inclusions. These would never be found in a natural diamond, and they are very obviously metallic, and they come in these sort of rounded rod-like shapes. So along with some other testing, these can be a good pointer for us. And if we look at the other side, the CVD grown synthetic diamond, often what we see are these graphite inclusions, which will be found in one plane. They're always just in one particular area, all aligned in one plane. So that can be another good pointer for us. We talked before about types of inclusions. And this particular type of inclusion is protogenetic. It's our clarity enhancement. So when the glass-like substance fills the fracture to improve the apparent clarity of the diamond itself, it is in fact a protogenetic inclusion. This particular image is from GIA. I think it's absolutely beautiful. Shows exactly what you would be looking to see if you were having a look for clarity enhancement in diamond. Now, some more unusual inclusions in diamond are these asteriated diamonds. Now, this particular case on the left-hand side, you'll see a close-up, if you like, of the diamond slices in this case. So these are probably 0.5 millimeter in thickness. But these are part of my collection, and I think they're just fabulous. So essentially, a lot of, or almost all of these asteriated diamonds come from Zimbabwe and have these loosely termed hydrogen cloud inclusions. When we put these under long wave UV light, ruined the surprise there. We can see these, the way that they glow, this beautiful luminescent neon. It almost reminds me of a sort of biohazard sign. But these are quite fun. But the most beautiful asteriated diamond I have ever seen is the Rhodesian star, which I think it's just simply one of the most beautiful things I've ever seen. This is courtesy of the GGTL labs in Liechtenstein. My friend Thomas Einschwang wrote a paper on this particular stone, and I'm sure you can see why. I have copied Thomas's words onto this slide because I don't want to get it wrong, because this is obviously another level of gemology, really. So I'm going to read this out just in case you can't see it all. But this particular phenomenon is caused by mixed cuboid and octahedral growth. So where the octahedral sectors are clear here, and the fluorescing orange or pink red, and the cuboid sector is being filled with particles and voids fluorescing green. That's what's causing these beautiful stars. The cuboid sectors are rich in hydrogen and nickel, and the green fluorescence actually originates from the nickel-nitrogen defects known as S2 and S3. So this is why I say they are, on my last slide, I called them loosely termed hydrogen clouds. That's the easy term for this type of thing. But Thomas is fantastic, and he goes, so much further in depth to this. And of course, these S2 and S3 defects that he's talking about if we're looking at these stones in advanced spectroscopy. Next. Moving on to the last part of my talk. It's a slightly shorter talk this month. I wanted to show you what I call chasing rainbows. A lot of this is using these cross-polarizing filters, which I mentioned earlier. Now these can be what I have is a folding travel polariscope from Gemquest, which I put onto my microscope. Or I also have an actual polarizing filter kit for the microscope. Just depends how much time you have, really. So the cross-polarizing filters, sometimes these can enhance inclusions. In particular, this image on the right-hand side here, I have to apologise, it is slightly blurry. The one thing about using cross-polarizing filters is that you can't get quite the same clarity of image sometimes. And in particular with this stone, there were lots of depths to look at. So even using stacking, you still can sometimes find this blur. But what we have here is when this particular stone was viewed just in normal transmitted light, you could see these needles were there, but they just appear as dark needles, and we can't tell much about them. But when we place these between the cross-polarizing filters and get them into the right position, you can see these beautiful interference colours appear. Oh, sorry, there we go. You can also see some evidence of twinning in the stone, some of these longer areas here, these flatter areas. These are all areas of twinning which you wouldn't be able to see without the polarizing filters. This particular stone is a cobalt spinel. This is from the Mahenge, Tanzania deposit rather than the Vietnamese deposit. There's not so much known about these particular stones yet, so unfortunately I haven't been able to determine exactly what these needles are. Moving on. Another area where we can use cross-polarizing filters to show something that would normally not be visible at all to the naked eye. These are demantoid garnet crystals from Balochistan, Pakistan. As we rotate these stones within the cross-polarizing filters, you can see this, what we call anomalous birefringence, where these beautiful interference colours appear within the stone. Otherwise, they're just lovely green crystals, but as soon as we place them in there, these rainbows just appear, which I think is wonderful. I wanted to show you a little video of what you can do with cross-polarizing filters also. This is just about 10 seconds long. think I hope you'll agree that you can get really beautiful results from using the cross-polarizing filters. Essentially, what we're seeing here is those interference colours and what we call the strain within the crystal, which is due to the way that it's grown in layers. And as you rotate it, you see these different interference colours coming from the layers within the crystal. And this is the Remora synthetic ruby. Oh, play again. There we go. And sometimes polarizing filters aren't required, and these beautiful rainbows just appear. Now on the left hand side here is the rainbow lattice moonstone, sunstone, sorry, which is from Northwest Territories in Australia. And this particular image is just taken with fibre optic lighting only, so it's reflected light, which reflects and shows these beautiful metallic luster inclusions and this beautiful iridescent colours. And on the right hand side here, this is just an incipient cleavage, which is on a diaspore from Afghanistan in this particular case. And again, just finding the right place, getting lighting just right, shows off these beautiful rainbows that were hidden in there. And that for this evening is my presentation. Thank you very much.
Thank you very much. I appreciate that, Sammantha. Now, I'm sure there must be a few questions from the audience. Can you help us out by, there we go. Anybody got any questions? Either put them on chat or unmute yourself.
I think Bruce has a question.
Yes, I have several. So how do you account for that unusual anisotropy within the garnet? Because the garnet, of course, is isotropic and it should just be totally extinct.
Exactly. But as we add in these cross-polarizing filters, we get to see this strain. Of course, sometimes it's called strain, sometimes it's called anomalous birefringence, but it's essentially all down to the growth of the crystal. So not all demantoid garnet crystals will show this. This is just down to the way that these particular crystals have grown and had this strenuous growth process at some point. I think it's really fascinating though that these particular stones all came from the same deposit and show this, whereas I have stones, similar stones from Namibia, which don't show it at all. So of course something must have happened in that general area for this to happen, which is it's quite fascinating, I think.
Yes, fascinating. Thank you.
I meant to mention actually this last image here. This was another one which didn't require polarizing filters or anything. This is a Tanzanian sunstone, and again, just fibre optic lighting. It hits off these lovely platelets, and you see these beautiful iridescent colours.
It's actually an interesting thing, if I can throw this in there, Samantha. We're looking at these star sapphire location in British Columbia in Canada, and unlike a lot of other locations where the star is as a result of the inclusions of rutile in lined as you showed in an earlier picture, these are actually aligned crystals of hematite, which
Read
are
about
giving
that.
with giving a star in the stone. I thought that was quite unique. I hadn't heard of it being in any other part of the world, having the asteration being caused by hematite.
I haven't heard of it being anywhere else, but I have a few Canadian friends and they were telling me all about them.
Ah, right.
Bruce has another question.
I had another one. So earlier in your talk, you talked about the epigenetic healing in the spinel. And then towards the end of your talk, you had the epigenetic clarity enhancement in the diamond, but you weren't calling it epigenetic, and I don't know why.
Sorry, I'm not sure what did I? Sorry, let me stop sharing a second. I was just looking back to see if I'd made an error there. So the clarity enhancement is a protogenetic because you've got the fracture, which has got the filling in, so it's something that occurred afterwards. And the spinel was also the same. That was also protogenetic. So, and what did I have in the epigenetic? I don't think.
Maybe just a comment from my side on the demantoids that you had. You listed that there are a couple of locations that do have these horsetails or these chrysotile fibers. I may add a couple more, like you may find it in Canada in the Jeffrey mine, and there's also new material from Pakistan coming in. They have, well, sorts of horsetails, and Iran, one of the two locations as well. Yeah. So there are plenty of them, and just I see many people saying you have a horsetail, it must be Russian. It's not true, unfortunately. It's not that easy.
I know there are some people who are very precious about their horsetails. Must come from Russia.
To be honest, I've never seen a horsetail look like that.
Maybe if it's very windy.
I was sort of hoping that Quentin might have a word or two to throw in there, being as he's also, like Bruce, involved in micromineralogy. In fact, he wrote the book on it.
Anne, I believe, has a question.
Willow, did Quentin have one?
I have one. I'm very interested in the formation of the TiO2 minerals in quartz. Have you ever seen an anatase crystal in amethyst?
Amethyst, no. In colorless quartz, yes, but not in amethyst.
I ponder why, because it occurs in smoky and in clear quartz, why it doesn't occur in amethyst. It has to do something with not the crystal structure, but the crystal chemistry. And I was just wondering if anybody had any thoughts.
That one's not a question for me, I'm afraid.
Well, it's certainly not one for me, other than to ask it.
Well, Anne is one of the preeminent quartz collectors in the world, so that's obviously an interest that she'd like to have.
Gladly
Right.
look into it.
I've got a question, Samantha.
Hi, Andrew.
It would be interesting to find out what the outcome is of the pom-pom quartz inclusion. Could it possibly be, or I'm guessing here, asbestos?
I don't. That's not one of the minerals that was suggested, as far
Okay.
as I. They had a list of sort of possibilities, if you like.
Yeah.
I don't remember that being one of them.
It
But
just has that look, just looking at the image, it just reminded me sometimes what I've seen pictures with asbestos and so on.
it's very fibrous in that same
Yeah.
way. It's also slightly iridescent though, which is quite
it?
unusual. Yeah. Even without putting it under filters, it was it's very interesting actually.
Perhaps you can put it out on the chats forums when they find out what it is. Perhaps they use a Ranon or something like that to find out what it is.
I think they were running confocal microramin on it, so hopefully we should have an answer quite soon.
That's good.
If not, as I say, it may be out there, so that's why I invite anyone, if they do know, please tell me. But I'll be in touch with Marco again soon and I'll ask him.
Thank you.
Well, I've heard bisolite and chrysotile, and chrysotile is definitely a form of asbestos. So,
It really does have that similar look for sure.
Yeah.
Well, I'm really looking forward to seeing the answer.
Bruce,
Yeah, I wondered what those red clouds were within that corundum that was in the forceps, because they were red and they were very pretty. And of course, in certain orientations, they were very apparent, and in other orientations, less so.
That was the synthetic ruby in the
Right.
video. Yeah. So the inclusions that are in there are from the flux. So they are just flux crystals essentially. So they're not actual, they're technically not actual inclusions, if you like, actual crystals, but they are just part of the flux, and they're very red, very deep red.
Thank you.
well, I think if there are no more questions, I want to thank very much. Thank you, Samantha, for putting this together. Thank you, Clemens, for being our amazing background person who makes everything work. And we very much appreciate your contributions. And all of you who attend, you give us your time and your interest, and thank you for doing that, because this is how we learn and expand our knowledge. So I'm looking forward to next month and months beyond. We do have some interesting programs that are in the works, and I'm hoping that we will excite you with them when we come to announce them. But at this point, I'd like to say thank you and have a good night, a good day, or whichever part of the day you're watching this in. And I hope that you've learned something interesting during this program. And I thank you, Samantha, for taking the time to put it together.
Thank you, Ray. Thank you, Clemens.
Thank you.
And